Okay, I am sharing my screen. Is my screen visible? Am I audible?
Yes, sir.
My screen is visible, right?
Yes.
Okay, fine. Okay, let us start. So, today I'll discuss, I think, all the problems sent by two students. First two questions sent by Aparna, she has some doubt, and second is Harish, some 4 or 5 problem based on angular momentum in quantum mechanics. So, I'll be covering all the things, and if you have any doubts from your, I will try to solve that after ending this all the questions sent by both of them. Okay. Okay, so the first question. So I forgot this question while I was discussing the 2021 paper. Thanks Aparna for reminding me. So this question from quantum mechanics, or you can say also spectroscopy chapter. I mean topic. Both is the. I mean this question overlaps both the topic. Okay, this question is a numerical answer type question. The question is the spin s vector, an orbital angular momentum L vector of an atom precedes about j vector. The total angular momentum is here j. So the j vector precedes about an axis fixed by a magnetic field B1 vector that is equals to 2 B naught z cap, where B naught is a constant. So we have a magnetic field which is constant in magnitude along the z direction. Now the magnetic field is changed to B2. From B1 to it is changed to B2. So that is B naught times x cap plus root 2 y cap plus z cap. Given the orbital angular momentum, quantum number L equals to 2 and spin quantum number is equals to half. Theta equals to angle between B1 and J for the largest possible values of total angular momentum number J and its z component that is Jj. So you have to find the value of theta in degree rounded off to the nearest integer. For the case of B2, so now the magnetic field is changed to B1 to B2. So for the second case, you have to find the theta. That's the question. So is there any doubt about the question? Just give me 1 minute, okay? Let me check. Okay, fine. Huh. So first read the question. The question is little bit larger. So first read the question carefully. And if you have any doubt, please ask me. So who are the participants today? Let me check. Today only 3 people are there. Okay, no problem. Okay, so is the question is understandable to everyone? I don't know.
Reading it, sir.
Just 1 minute. Just 1 minute. Is it visible, right?
Yes, sir.
Okay. So everyone read the question carefully first. Let me know if there is any doubt. Aparna, you are getting any difficulty in understanding the question first? You can ask me.
Sir,
Yeah.
I have some difficulty
Uh-huh.
since it's a large question.
Yeah, large question. So, but question, the statement is not so hard. I mean, what statement is given here, although the question is large, that statement is very clear here. Okay. And also the question is not too tricky, it is straightforward. You have to understand little bit what is asked in that question first. Okay. So what's the difficulty first I want to understand from you? I mean, why are you getting stuck here? Can you please ask me?
Sir, I am unable to do this question from the beginning itself. There is
Okay.
some difficulty.
Okay. Okay. So let me clarify this question first. Okay. So the question is basically here it is asks, you can see the second line, J precedes about an axis fixed by a magnetic field B1, that is along z cap direction. So usually we define our quantization axis along z axis, right? So that is the z component of the angular momentum or total angular momentum that will be aligned along the your magnetic field axis, right? And around that your j vector will be precise. That is called Larmor precision. You have studied, I think, right? Larmor precision. Anyone knows? Anyone? Amit, Sejal?
Yes, sir.
Okay. So that's the thing here, it is given, but it is given as a statement. Okay. So first thing you have to understand from here, your z component of the j will be aligned along b1 axis because your magnetic field along z cap direction. So your jz or z, so there will be a projection of j along that magnetic field direction, and that is the theta. So there is given some condition that you have to consider the maximum value of j and its maximum value of jz component. So you will have a range of j component, right? Because you have L equals to 2 and S equals to half. So how will you find the j value for this particle? That is, I will give you a hint. So that is the ranges from L plus S to mod of L minus S. There is possible j values, right? Am I right? You got the
Yes,
point,
sir.
right? So
Yes.
among that range
Yes.
you have to pick the maximum value of j, and for that j value you will have multiple of jz values that ranges from minus mj to plus mj, right?
Yes.
So you have to pick the
Yes.
plus maximum of plus mj value. So that's the condition given here. So for that the theta is defined here, that is given in the question. You can read the question. Theta is angle between b1 and j for largest possible values of total angular momentum value j and z component of jz. So that is given here. So so what you have to do here, first the procedure to solve this question is, first you have to find the theta for the magnetic field B1. Okay. First, that is the initial angle you have to find. Then magnetic field is changed. Then for you have to find the angle for the second case. So basically, first angle you have to, why you have to find, because if you are changing your B1 to B2, basically your z component of j will be aligned to B2 axis. So if you can find the angle between B1 and B2, then you have to just add those two things, right? Because initially you know the angle B1 and j. If you, and you can easily find the B1 and B2 between that angle, then just add them up, you will get your answer. I already
So,
told, yeah.
so if theta is the angle between B1 and J, then what is the need of B2?
No. But that is the question. Now, first B1 theta is initial. That theta is initial angle between B1 and J. That the question that has been asked here. What is the angle when B1 is changed to B2? That's the question. So then your theta will be changed, right? Because the magnetic field direction has been changed now. But the magnitude is same here. You can see the magnitude is 2b naught in both the cases, right?
Yes.
Yes. So that's the question here. So what I said, you have to find the initial angle first. You can't directly find the B2 and J angle because here the quantization axis has been changed now. So that is not usually familiar to us how to find these things. So first the procedure is, you find the initial angle and then find the angle between B1 and B2 and add them up, because it will be just shifted towards B2, right? If you can find the angle between B1 and B2 and B1 and J, then just add them up, you will get the final answer. That's the thing. I mean, is this clear? I mean, what I have said. If you have any confusion, please ask me. Although I will be discussing the
Clear,
solution.
sir.
Yeah. Who's this? Yeah.
It's Barna.
Yeah. Please ask me. Yeah.
This is by Lamar's precision.
Yeah, the concept, the precision is called Larmor precision because your angular momentum doesn't have any particular, because this is a axial vector, right? So why it precises, the concept of angular momentum comes, you can't have a proper starting point, ending point, right? So that's why you define the angular momentum has certain direction, but its projection is along the your magnetic field axis and it precises around that. That's why the precision comes. You don't have a particular fixed direction of your angular momentum or total angular momentum. That's why it precises. You can't identify the proper direction. It will not be fixed. If you have read the Larmor precision with phenomena, I think it will be clear to you. But that concept is not needed here. I mean, that is already given. You don't have to apply the hardcore concept of Larmor precision here. Although,
So
yeah.
Okay, sir.
for the angle between J and
Yeah.
B1,
Yeah.
I'm getting 32.33 degree.
Okay.
Then what should I do?
Okay, then what I have already said. So see, so you found the angle theta to some theta, right, for B1 and J, right? So you have taken the J value of maximum value and JZ value of that, I mean, Z is equal to J value because this is the
Yes,
maximum value of
we
JZ, right?
actually did the same thing in another problem, similar
Yeah,
problem, but
yeah, 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 yeah. Right, right, right. That angle we have to find, right, for angular momentum.
yes,
I remember that. I think last to last session or last to last class. Okay. Anyway, so you found that, right? So you did the first step. Now you have to go for the second step. So that is what. So now you are changing your B1 to B2, right? So basically what the j value will so basically how the jz value will incline to the b2 axis. Now you have changed your b1 to b2, so basically it will just change its alignment along b2. So if you can find the angle between b1 and b2, so that is the additional angle to the your j and b, right? So you have to just find the angle between b1 and b2 and add with that theta, what you get 32 point something, right?
yes,
So that will be your final answer because your that will be aligned along B2 right now, your JZ value. Now you don't have to find explicitly your J and B2 between angle between J and B2. Just find the angle between B1 and B2. I mean, you got my point, right? What I am to say. Anyway, you just do that and let me know the answer. I will explain whole the thing in my solution. Okay. Just do that and let me know the answer first. So you are correct. Okay, your theta value what you got, that is correct. 32 point, I think 3 point something. I forgot. I have to check. Yeah, 32.3 around. That will be B1 and J. So Aparna, is it? Did you? So are you able to find the value of J and JZ for this case? First thing you have to do that. Or Sejal, you are there?
Yes, so that's 60 degrees.
So B1, B2 is 60 degree. Or initially you got
Yes.
32 point something, right? You got that, right? How to find that? You got the point? I mean, how to find the angle between J and B1 here?
I was just going to do that. I first found between B1 and B2.
Okay, okay. That's correct. That will be 60 degrees. So basically, Amit, I think you found your answer 92 point something, right?
yes, almost, yes.
Yes. So basically, the okay. Let me go to the solution part. I because I have today 8 questions to ask solve, because I think Harish is not there. Harish joined today because he sent me 5 questions to solve. I mean, if he is not joining,
No, he
then
is not there.
okay. Anyway, we'll be discussing that question was good question, so it will be helpful for you guys, even though he is not there. Okay, so the answer is either 92 or 93. So that will ranges from, I mean, you will get a fractional answer, but it you have to write the integer form. So either it is 92 or 93. Okay, so I'll go to the solution part. Let's see. Okay, so first thing is related to your course spectroscopy. If you know this, I mean, how to find the total angular momentum if you know the orbital angular momentum and your spin angular momentum, right? So here it is given your L value is 2 and S equals to half. So your total angular momentum quantum number will be ranges from L plus S to mod of L minus S, right? So it will be ranging from 2 plus half to 2 minus half. So you will get only 5. First it will start from 5 by 2, then there will be difference of 1, right? So next value will be 3 by 2, but it will end up to 3 by 2, so there will be only 2 possible values. Now it is given in the question that you have to take the possible largest values of total angular momentum quantum number. So you will pick this first one, right? 5 by 2, largest value. Now for this 5 j value, your mj value will be ranges from minus j to plus j, right? So your mj, that is the quantum number for your z component of j and jz value, right? So that will be 5 by 2, 3 by 2, half, minus 3 by 2, minus 5 by 2. Is this clear to everyone? Aparna, is it clear to you?
Clear till now.
Okay, fine. So now the magnetic field B1 is along z direction, right? The angle between the largest value of j and B1 is basically your your projection of j along the B1 will be your z component. That I already told, right? That is clear. Is this clear to you?
Yes, sir.
That is how we define our JZ component or LZ component. Okay, when you apply a magnetic field along some direction, so your basically your Z component of that is a quantization axis that will be aligned to your to that direction applied magnetic field. That is your quantization axis. That may be any direction, but usually you define it along Z cap direction, and that is also given in the question. That is a standard thing. So basically theta is the angle between your J and B1. Now it is given in the question that condition you have to get take the values of jz and j for the maximum value. So here jz will have mj each cut, and this j mod j will have root over j into j plus 1. Now we already found that maximum value of j is 5 by 2, and also mj maximum value is, that is the quantum number for jz, that will be 5 by 2. So just you have to put that. So basically from here we will get the angle between j and b1, given that the condition you have to take the maximum value of j and jz. That's the thing. So this is the formula, right, to find a theta for this j and b1. Now put that mj and j value. So what you will get, 5 by 2 for mj and j value is 5 by 2. So we put that, you will get cos theta equals to 0.845. So theta you will get 32.31 degree around. So this is for your b1 and j. Now so angle between largest value of j and b1 is now 32.31 degree. So this is not the question asked in the, this is not the thing asked in the question. Now it has been told you are changing your magnetic field from b1 to b2. So you can see the magnitude of the magnetic field is same, but the direction has been changed now. So what will happen? So you are changing your quantization axis now. So easiest way to find, so you know your z component will be aligned along b2 axis. So directly you can find the b1 and angle between b1 and b2. So what I will do, the angle between magnetic field b1 and b2 is, you just apply the dot product formula. So you will get, so phi is the angle between b1 and b2, you will get half, cos phi is equal to half, so this is 60 degree. So basically you are changing your quantization axis or b magnetic field axis from initial to final by 60 degree. So the angle between largest value of j, for largest values of total angular momentum number j and its z component jz, and b1, which is changed from b1 to b2. So basically now your magnetic field is not b1, it is b2. So you have to just add this up, because you have shifted your magnetic field axis from initial to final by 60 degree. So after that you will get 92.31 degree, and that will be your final answer. Okay, so is there any confusion? Please ask me. Just think about it. If you have any confusion, please ask me. Apanda?
Sir, that in cos theta part, you took mj as 5 by 2.
Yes.
That's from that equation now.
Yes, because here first we found that what is the possible values of j, right? So in the question it is given that you have to choose the maximum value or largest possible value of j as well as largest possible value of jz. So okay, so largest possible value of j is here 5 by 2, that we found, right? And we know
Yes.
for total angular momentum, this is total angular momentum, yeah. So for that, the z component of j, that is jz, will have the quantum number mj, right? That you know, that ranges from minus j to plus j. That is similar to your lz, minus l to plus l, right? Similar
Yes,
thing. So for that you have this much of quantum number for jz. And also given in the question, you have to pick the largest possible value for jz also. So we will take this j equals to 5 by 2 and jz equals to 5 by 2. That's the thing we have done here. So that
now clear.
Yeah. Okay. And everything, I think that was straightforward, only calculation. You have to do that, you have to add this up. This question was like that. This is pretty simple, but you have to understand this, what is asked in that question. So Amit, I think you got it correctly.
Yes, sir. But if you see in the question, sir, they are again asking the theta, so it is quite confusing.
Yeah,
actually.
I got your point. So basically, okay, theta is the angle between b1 and j for the values of total angular momentum j. Yeah, but the question now magnetic field is changed to B2. I think question was a little bit confusing, but I checked the
Yeah.
answer actually. It was 92.31. So I think this is the way to solve this question. Okay, yeah, I got your point. This was a little bit confusing. But then there is no need to give the B2, right? If that is the thing, right? Am I audible? Hello? Yeah, sorry guys, the connection was interrupted. Okay, let me share my screen again. Okay, is this visible?
Yes, sir.
Okay, so yeah, so that I was saying, so then there is no need to give the B2, right? If that is the thing that has been asked in the question. So I mean,
Yes, that was actually I
ah,
was asking it for.
yeah. So I understand. There's a little bit confusion in the question, but this has been asked exactly in the question. What I have told. Okay, fine. Will I proceed with the next question or there is any confusion? You can just ask me now because I will be covering today 7 to 8 questions because it will take time.
Yes,
Everything,
clear.
okay, clear, Aparna? Okay, fine. Okay, then second question. Okay, so answer is 92.93. Okay, fine. So this question I have already discussed, Aparna. Okay, let me do one thing. So I think all of the students, anyone has was in my last session class and faced this question. Can you please tell me?
Sir, last session there was no class now.
No, last session means I am saying before November. I mean, this is a session 2 going on.
Okay.
There's two part of this NPTEL GATE course. First part we completed in
Okay,
3
sir.
months. So that time I was discussing the 2021 question actually. Okay. So I think all the quantum mechanics, condensation, solid state and atomic physics question I covered in that 3 months. And now I am proceeding with 2022 and I already finished that. Now, so this question was discussed there. So anyone was there at that first part? I
Sir,
don't.
I joined by October end.
Oh,
So
okay, okay. I
I
think
don't
you.
remember this one.
Okay. Anyway, so you can give it a try. Okay, I can discuss it today also, no problem. But this has been already discussed in the last session. Okay. So the question is, this is from 2021 paper. This is also a numerical answer type question, and this is from solid state physics, basically from magnetism. So the question is, consider an atomic gas with number density n equals to 10 to the power 20 meter per meter cube in the ground state at 300 Kelvin. The valence electronic configuration of atoms is F7. The paramagnetic susceptibility of the gas chi equals to m times 10 to the power minus 11. The value of m rounded off to two decimal places is, you have to find the value of m here for the paramagnetic susceptibility. So there some informations are given. First you know that mu naught value, that is the magnetic permeability for free space, that is 4 pi times 10 to the minus 7 Henry per meter. Bohr magneton, you need this, that is mu b equals to 9.274 times 10 to the minus 24 ampere meter square, and Boltzmann constant it is given joule per Kelvin in the unit, that is you know already 1.3807 times 10 to the minus 23. So this information you have to use here. And so can anyone say first what's the formula for paramagnetic susceptibility according to quantum theory of magnetism? Anyone? You have to remember that, otherwise you can't solve this. Amit, Sejal, or you can just
Sir,
see your books and let me know. See your
okay.
books and let me know what's the formula. Okay.
Sir, n nu 0 nu b square by 3 kbt into p square.
So
I think that is
what is p square? Can you say?
g into root of j plus 1.
P square is g into
P
root.
is g into root of j into j plus 1.
Okay, so basically that is related to your total angular momentum and your Landau factor, right? Right.
Yes, sir.
Yes. Okay. So basically everything is given here. You have to find the Landau factor for this case. Only thing, everything is given, right? You can see n is given here, kb is given here, t is given here, j you have to find here, and also if you can find the j, also Landau factor formula you have to know for this. What is the Landau factor for total angular momentum in terms of total angular momentum and spin? Can anyone say? This is a little bit informative formula based question. Nothing. If you can remember that, you can easily solve this. You can see your books and if
Sir,
you.
in the numerator, I think we have JJ plus 1
Yes.
plus LL plus 1 minus SS plus 1
Yes, right.
and divided by 2 times
2 into j plus
I
1, you are
forgot.
saying right. Okay, I'll
Yes.
let's do one thing. I will not spend much time because this is properly. So basically you have to, the thing here you have to find exactly what's the j value for this system, then you have to find the g value, that is the Landau factor, then apply to the formula. That's the thing. There are 3 steps here. Okay, I will go to the solution part. Okay, just check and you can revise yourself. Okay. Okay. So according to quantum theory of paramagnetism, we have chi para equals to mu naught in mu j square. So what Aparna said, that I represent, some books represent it like this, that is okay, by 3 kbt. Okay. So here mu j is basically gj times root over j into j plus 1. I think Aparna said you this is as p, right? P times mu b, right? Aparna?
Sir, in first paramagnetic susceptibility, there was into p square was there. I don't know.
This is the
I'm
p.
not sure.
You can see mu j equals to p mu b, so that will be p square mu b square. This will get. So
Yes,
that's the
yes, sir.
thing. So it's okay if you can remember like this. That's also fine. That's okay. I usually remember like this. Okay. So basically here you see the unknown quantities are gj, that is the Landau factor for this system, and j value, right? This thing if you can find, and other than the mu naught you know, n you know, kb you know, t you know, mu b also is given in the question, right? Mu b is given in the question. So in your question these things are given. So to find the j value, because gj value will depend on your j, l and s. So first you have to know the information about the system, that is j, l and s. So for that we have to use this. The valence electronic configuration is given F7. So basically your valence electron, as the outermost electronic shell, is configured as F7. So let us see how the electronic arrangement is there. So for F7, basically if for F, you know L value is 3, right? For S, L equals to 0, P equals to 1, SP, D, F, D is 2 and F is 3, right? That you know, right? Is it clear?
Yes, sir.
Okay. So for that you will have ml value plus from minus 3 to plus 3. So basically you will have 7 energy levels, or you can say 7 partitions in your shell where electron can occupy here, right? So every partition will contain your 2 electrons for spin half, spin plus half, spin minus half. Okay, so you have 7 electrons because it is given as F7. So you have 7 partition, you have to your allocate your 7 electrons in the 7 partition. So all the partitions will contain 1 electron here, right? So for all the electron, the ms value will be plus half or either minus half. Usually we take first occupation as plus half. That's okay. That will not make any difference in our answer if you take also minus half here. So you see, for that total spin quantum number s, that is summation over ms. So that will be 7 by 2. But we know that is the full filled or half filled orbital will have total orbital angular momentum will be 0, because it will be plus minus 3 to plus 3. If you sum up all of them, you will get 0. So you got your total S, total L for this question, right? Is it clear up to this? Up or down?
Yes, sir.
Yeah.
Yes, sir.
Okay. If you have any difficulty, please ask me. These questions are, I think all the questions are related to spectroscopy somewhere, right? So these things, I mean, 1-2 question you will definitely get from this topic, these concepts. Okay. So your now total angular momentum is your L plus S, right? So that is your 7 by 2 plus 0, that is 7 by 2 here, right? Is it clear?
Yes.
Clear, sir.
Okay. Now you know the J value. So one part is done here. You know the J, this part you can calculate now easily, right? Okay. Now we'll go to, so one more thing, sometime it's asked in examination that what's the spectroscopic term for this system. So usually this is not relevant to our solution. Okay, that's okay, but this will be, you know, right? This representation is 2s plus 1 Lj, where s is your total spin. So here total spin is 7 by 2. So you will get 2s plus 1 as 8, and L value is your 0. For 0 we represent it as s, right? And J value is 7 by 2. So the spectroscopic term for this system will be 8s 7 by 2. Sometime it is asked in the question also. That's why I thought it should be included here. Anyway, let's come to the topic. Now Landage factor. That formula is Gj equals to 1 plus j into j plus 1 plus s into s plus 1 minus l into l plus 1 by 2j into j plus 1. This thing you have to remember. Okay, and please remember it, because sometime, I mean, I have seen, I mean, at least in one question you will be required to calculate these things. Okay, because I think last year 2022 also some question were there relating to Landage factor. Okay, so so we have s equals to 7 by 2, l equals to 0, and j equals to 7 by 2. Just put it there. So you will get gz equals to 2. Is this clear? This is totally calculation and formula based. Is this okay?
Yes, clear.
Okay. So we have now gj value. You have the j value. Just put the values there. So how I basically this mu j is known as effective Bohr magnetism. Effective magnetic moment. So this is basically the correction to the Bohr magnetism. The correction term is your p term, what you have said, gj times root over j into j plus 1. So that is the correction term. Usually that was not considered earlier. That's why then the calculations or was not matching with the experimental results. Then that quantum theory of magnetism has been started. Why this is not matching and what is the correction factor needed? And that's the correction factor, gj times root over j into j plus 1. Okay, so gj is 2 and j is 7 by 2. Just put it there. So basically your effective magnetic moment is root over 63 times mu b. So you put the mu b here and you put in the formula. I think there is nothing to discuss here. That is the total calculation. You will get m equals to 5.48. Is it okay? Just see the steps. If you have any doubt regarding the steps, please ask me.
Clear, sir.
Okay, fine. So here you can see what you needed. First, you needed the concept of how to arrange your. You have to know the electronic configuration in your system, that is given already. Just you have to allocate your electrons to the particular energy levels. You have to find the total angular momentum, orbital angular momentum, total spin angular momentum. From that we found the total angular momentum, that is J, and from that we found the Landage factor, and then we applied the formula. That's the thing. So basically you have to find the j and mu j value here. That's the thing. Okay. I think everything is clear to everyone. Anyone? Sejal, Amit, or anyone else there? I didn't see
Yes, sir.
whoever has joined here. I think, okay, 3 people are there. Okay, fine. Okay. So I think these are the 2 questions from Aparna, right?
Yes, sir.
Okay. So I hope you this is clear to you. Okay, so now now last I think 4 or 5 questions that was sent by Harish, and I thought that should be discussed because quantum mechanics is some topic, huge question is asked from the topic. So he sent some questions regarding angular momentum. So I thought that should be discussed. That would be helpful for all of you. And that is the previous year's question, the older question, but the questions are interesting. Okay. This question was from GateFace 2000. This is from quantum mechanics. The question is pretty simple, straightforward. That is, a spin half particle with g greater than 0, that is the Lagrange factor greater than 0, is subject to a magnetic field H equals to H naught z cap. Okay. If the quantization axis is along plus z cap axis, then the minimum energy eigenstate will be, first option, downspin state. Second option, 1 by root 2 times upspin minus downspin. Third option, upspin. And the last option, 1 by root 2 times upspin plus downspin. So you have to find the minimum energy eigenstate for this system. Hamiltonian is not given. Usually this is given magnetic field. So so can you say what will be the Hamiltonian for the system? Anyone? Magnetic field is given. So what will be the
Mu times
energy?
B. Mu
Sorry,
dot B.
minus mu dot b. Here students
Minus
do the
mu dot B.
mistake. If you do plus mu dot b, then you will get total different answer. Minus mu dot b. So now here mu, what will be your mu? That is the mu is your magnetic moment, right? Here you are not given the information, any information about the orbital angular momentum for this question, right? So only spin is given. So here you have to consider the only spin magnetic moment, that is mu s. So that will be minus mu s dot b. So what is mu s? The expression for mu s, anyone can say? Anyone?
So the one we just wrote, it will be replaced with gj
So
times
what?
s plus 1 under the root times mu b, right?
You can keep the g as that's the effective Lagrange factor. You don't have to consider the root over j into j plus 1 or s into s plus 1. You can say it as j. You don't have to focus on that part because here you really don't need to calculate the g value, right? That's okay. So basically what will be the expression? That will be g times mu b, obviously not mu b, actually g times mu b, that is be e by 2m, right? Mu b is e by 2m, right? If I am not wrong, e h cut by 2m, sorry, I think so, e h cut by 2m, yeah, no, sorry, e by 2m, I was correct. So basically your mu s will be gs time mu b, that will be e by mu gs times e by 2m, right? Times your spin will be always be there, that will be s vector. So basically your Hamiltonian will be minus gs e by 2m times your spin vector, that will be your mu s, right? Dot product with your magnetic field, that is h naught z cap. Is it clear? Or
Yes, sir.
okay, so can anyone say that actual, so after doing that what will be the expression for your Hamiltonian? Because there is a dot product, so after doing that what will you get? Is this clear or I will explain again? I mean, if you have confusion, please ask me. Sejal?
So here it's written that the quantization axis is along z, so it means that the spin is oriented along z, right?
Yes. Actually,
So then cos theta is 1.
so that is given actually why? see, your quantitation axis along z axis, your magnetic field is along axis, also along z axis, right? So that is the information is given. That means your projection of the spin will be along z direction, right? So that will be your sz. So that is given because when you will do the minus mu s dot h vector, that is the magnetic field vector, right? So what you will get, gs mu s is your gs e by 2m times your spin vector dot product with your h naught z cap, right? Right, Sajal? So s dot z cap actually basically will give you the projection along z direction. That will be your sz, right?
Okay, so it's redundant, right? We don't require that the quantization axis along z. That's
Yes,
understood.
that is given because I mean, if it is given, then you have to think about it. But it's already magnetic field is along quantization axis, so you can consider that the usual problem that we consider. Your z direction is the quantization axis. I think in every problem we do that. If something is not told in the question, that's the thing. So
Okay.
yeah. So what will be your Hamiltonian then? So you will have a sz term, right?
Minus g mu b s z h naught.
Yes. So if you can find the Hamiltonian, then can you say what will be your minimum age eigenstate? Because energy depends on your Hamiltonian, right? And for which state the energy will be minimum? The Hamiltonian eigenvalue of Hamiltonian will be minimum.
So for sz equals plus half.
That is, so in option that is
That is C.
yes. So C is the correct answer for this question. Okay, let me discuss the solution quickly. I mean, that is I already discussed. So your magnetic moment due to spin of particle, like electrons, you can say, your mu s will be gs times e by 2m s vector, right? So given magnetic field is this, so your Hamiltonian for this system will be minus mu dot b. Here it is h, so mu h you can say. So it is like minus gs times, this is mu b here, e by 2m. I have written it here like this, s vector dot h naught z cap. Now s dot z cap will give you the z component of your spin, that is sz. Here gs is greater than 0 because it is given in the question, the Landesi factor should be greater than 0. So eigenstate of h is same as the eigenstate of sz because your h has the expression for only the operator is sz here. So whatever is the eigenstate for sz, that will be eigenstate for your Hamiltonian. So sz has the eigenstate of either upspin or downspin with the eigenvalues h cut by 2 and minus h cut by 2. Okay. For up state, you will have the energy. So you have to put the sz equals to plus h cut by 2. If you put that, you will get this energy, right? Minus h naught gs e h cut by 2a. Okay. And your down state, it will be, you have to put the minus h cut by 2, you will get this value. So here the importance of giving the gs value greater than 0, because it will really depend on which state will have the maximum, or in not in magnitude, with sign also, which state has the maximum energy. So for this here up spin state, it has the negative energy, right? Because gs is greater than 0, so it's the minimum energy state. So the minimum energy state is here up spin, right? So is this clear to everyone? Any confusion? Anyone?
Clear, sir.
Okay, fine. So this question was, I mean, I think this was a good question. Okay, so the option C is the correct one. Okay, going to the next question. It is given that if a spin one particle is in the state m equals to 0, so basically the azimuthal orbital quantum number is given, m equals to 0. Sorry, this is related to your spin azimuthal quantum number, because there is nothing given about the orbital angular momentum. Okay, m equals to 0, it is not specified here, it should be ms equals to 0 with respect to quantization axis n cap. Which of the following is correct? Option A, expectation value of your spin vector will be 0. Option B, expectation value of the spin vector will be n cap, that is your quantization axis, along quantization axis. Option C, that will be expectation of s vector will be root over 2 n cap, and last option, expectation of s vector will be minus n cap. So you have to find which option is the correct for this question or for this system. Okay, how will you do that?
So it should be A, right?
Okay, why it should be?
So because spin 1 means it can take values from -1
Ha.
and 0 and 1, and since it says that m equals 0,
Hmm.
so it is s equals no, if m equals 0,
Hmm.
then it's is it mine is it it'll be s equals 0, no?
So
I
I mean
mean
I didn't get your explanation. I'll not say what is the correct answer, but can you explain it again? I didn't get your point. Can you say
Sir,
again?
I'll just take a minute to rethink.
Okay. Just rethink and let me know. Okay. This question is very simple. If you just, this is a fundamental question has been asked. You have to do 2-3 steps to get the answer. Okay. Just think about this. So let me give you a hint first. One hint. Just expectation of S vector is you just split it into components x cap, y cap, z cap. Just then think about the expectation value of Sx, Sy, and Sg. This is the hint from me. Now let me know the answer. Aparna, Amit, is this okay? I mean the question is clear. What has been
Yes.
asked, and I have given a hint. Please use that, and you will get the answer. It will take hardly 2-3 lines to do.
Sir, can you please repeat the hint once again?
Okay, so see, you have to, basically the question is related to your expectation value of S vector, right? So what we can write is S vector is basically will have three components, that is x, y, z, right? In 3 dimension, right? So you can write it S vector as Sx x cap, Xy y cap plus Sz z cap. Now if you take the expectation, so that will be applicable to both the sides. So you can write expectation of S vector is basically expectation of Sx along x cap direction plus expectation of Sy y cap direction plus expectation of Sz along z cap direction. Now think about the expectation value of Sx, Xy and Sz explicitly. Then put the values and you will get the answer.
Now clear.
Yeah. Okay. Also, I think, what about the expectation value of S vector that I have discussed in some classes? I remember while discussing the orbital angular momentum, how to find the expectation value of uh, Lx,
Ladder
Ly,
operators.
huh?
Ladder operators.
Yes,
Using them.
yes. So if you remember that concept, then you don't have to calculate. You just remember the concept, and you will easily comment on the answer. You don't have to even calculate the average of Sx or average of Sy. What will be that? That should be 0, right?
Yes.
So you have to find the only average of Sj. So do you guys know why? So I have already discussed. If you have attended my, I think last I forgot exact class. I think 2 weeks back I discussed this problem related to angular momentum, that is L. Same concept is applicable to spin also. Same thing. The operations or mathematical operations will be same to find the average value of Sx and average value of Sy while given the quantization axis along z cap. Uh, was the hints were useful, or you need more hints to find that? So Amit,
Sir, I haven't revised it well.
I have told everything. You have to just do one line to get the answer. Then, if you have more average of expectation value of S6 0, SY 0, you can't find the expectation of SZ. That is simple thing. What will be expectation of SZ? Can anyone say? What is the formula for SZ? Let me know.
Sir, SZ is straight away 0 from the question.
It is given in the question, right? It is MS times H cut, right? MS is given 0, so it should be 0.
Yes.
Yes. So the answer is 0 here. Okay. This I see. I wrote this much of thing even though I completed half of the page. So okay, this was only 2 lines solution. If you have to just remember what is the expectation value of Sx and Sy. That is 0. Every time you remember that, if your quantization axis, whatever is your quantization axis, other than that, every term expectation value of will be 0 because it will be precise, right? Preceding. So the average value of Sx and Sy will be 0 always. So here you, if you just split in this 3 terms, in this case, that is expectation value of S is expectation value of Sx, expectation value of Sy and Sz along x cap, y cap, z cap direction. So this is 0, this is 0. And how to find that, do you know? I mean, did you attend the last few classes? I mean, how to get that average of Sx 0, average of Sy 0? Can anyone say?
Yes, the letter operators will,
Yes.
after operating them, the all the states will be orthogonal.
Right. So basically, you can represent this Sx Sy in terms of S plus S minus, right? Now S plus S minus, so it will, I think I forgot the exact expression. It will be Sx, I think S plus. So basically, S plus is Sx plus Ixy, and
S
S
plus
minus,
plus S minus by 2.
yes, and Sy will be S plus plus S minus by root 2I. No, I just let me think. Okay, so let me tell you. I have to just use the copy. S plus is your Sx plus Ixy, right? Aparna,
Yes.
do you know this ladder operator?
Yes, sir.
Okay,
I
so let
attended that class.
okay, let me tell you how to. I mean, if you don't know, let me tell you how to find this. I will just tell you very briefly. You can just do it in your copy. So basically, S plus is Sx plus Isy, S minus is your Sx minus Isy. So just represent the Sx in terms of S plus and S minus. So what will be? It will be your S plus S minus by 2, right? Am I correct, Amit?
Yes, sir.
And Sy is S plus minus S minus divided by 2I, right?
Yes.
Okay. So now see why you don't have to do the mathematics also here. So you can represent the Sx in terms of Ss plus S minus by 2, and Sy is S plus minus S minus divided by 2y. Now if when you are doing the expectation, that means you are taking the same state on the both the side. You are sandwiching your operator in between that two same state. Now ladder operator, what you will do, it will raise the state, right, or it will decrease the state by 1. Now when you do the orthogonality, you will do the dot product or inner product between the two states, you will get always 0, right? Is this clear, Aparna?
Yes, sir.
Is the statement clear? I mean, I am not doing the mathematics, I am just saying you the logically why it should be 0. So basically these two, when you
Yes,
will
sir.
use the ladder operator in these two terms and you will take the expectation, you will see due to the orthogonality you will get always 0, these two terms, right? Only this expectation value will have the MSH cut. So basically the expectation value of S vector is basically MSH cut times your quantization axis, that is the Z cap. Now MS is 0 given in the question, so just put it here, you will get 0. That's the thing. Okay, right? Will I proceed?
Yes, sir.
Okay,
Yes,
so
sir.
option A is correct. Okay, Sejal, is this clear to you? I think you got the correct answer.
Yes, sir.
Okay, fine. Chalo, next question then. This question, This is also an easy question. I hope you'll be able to answer this question. The Hamiltonian of a particle is given by h equals to p square by 2m plus v as a function of mod r. So that is central potential plus another central potential term, that is phi as a function of mod r times L dot s, where s is the spin of the particle and L is the angular momentum, orbital angular momentum. Vr and phi r is your potential functions and L is as usual angular momentum, orbital angular momentum. The Hamiltonian does not commute with, so four options are given: L plus S, B is S square, C is Lz, D is L square. So this question was asked in GATE Physics 2004. Okay. So which options doesn't commute with your Hamiltonian? You have to find them. Please try. So what will be your what will be your first step? Can you please tell? Anyone?
So
So we will write L dot S in terms of L and S. For example,
Mm-hmm.
will be L plus S
Mm-hmm.
minus L squared minus S squared.
Okay. So what is your L plus S basically? L plus is oh, so okay,
J.
this is J. Okay, it's fine. L plus S is J, so you can write it like that. Okay, yeah. So that's correct. So then what should can you comment from there? That is correct. So after that you have to comment. You see the options and let me know the answer. You don't have to do any mathematics after that. This is my
so
hint.
B.
Why B?
Uh, so because if we write the L dot S as Lx Sx plus Ly Sy and then Lz as Z.
Hmm.
So L square will commute with all of that. Okay, Lz should be the answer.
Hmm. Okay. So basically, the simply if we can say, if you represent the L dot S as my right j square minus L square minus S square by 2. So what Sejal has said, I think Sejal said, right? L plus S square minus L square minus S square by 2, right?
Yes, sir.
So basically you can see L plus S is J. So your Hamiltonian will be eigenstate of J or J square, L or L square, and S and S square, because your Hamiltonian contains these three terms, right? So that your state should have these three quantum numbers, right? So only thing it doesn't contain, that is Lz. It is eigenstate of your L square or L, but not Lz. This is the beauty of this Hamiltonian. So basically I will go to the solution. I will not explain much because I have already told. So you have to represent the Hamiltonian like this. Okay. And so what you will get, so you can see from this Hamiltonian, if you just take the commutation h with s square, so what you will get, L square, so j square commute with s square, so you will get essentially 0, right? Because this is a, this Hamiltonian is a eigenstate of same as the s square, L square and j square, right? Also J, L, S also, but there is no Lz. So whatever eigenstate you have, that will not be the eigenstate of Lz, because your Hamiltonian doesn't contain any Lz here directly. So it will not commute. You will have certain value. I have not calculated. I have to see what will be. Okay, you can try, but the answer will be C. That will be Lz. Is it clear?
Yes, sir.
Sejal, Aparna.
Yes, sir.
Yes, sir.
Okay, fine. So I'll go to the next question. So okay, this was the question from 2007. So from quantum mechanics it is also. So this is three operators x, y, z satisfy the commutation relations, that is commutation of x and y is I h cut z, commutation of y and z is I h cut x, and commutation of z and x is I h cut y. The set of all possible eigenvalues of operator z in units of h cut is, so option A is given 0, plus minus 1, plus minus 2, plus minus 3, and so on. Option B is half 1, 3 by 2, 2, 5 by 2, and so on. Option C is 0, plus minus half, plus minus 1, plus minus 3 by 2, and so on. And last option D is minus half plus half. This is a little bit interesting question. you don't have to calculate is do mathematics much, but if you can identify the what has been asked here, you can easily tell the answer. So
So by identifying the XYZ,
yes,
so LX, LY, and LZ, I guess.
see, there is possibility of three operators. So one is it can be LX, it can be SX, right? Because that's thing
Yes.
follow this. Also your G, total angular momentum, right?
Yes.
So it can be all possible three. So now your J will have the all possible value of that eigenvalues or yeah, eigenvalues. So it is asked in the question the set of all possible eigenvalues. So you have to find the most possible operator here, and that will be your total angular momentum, not only the orbital
C.
angular. Yes, it will be option C. So I mean,
Yes.
sometime if we consider the LX, then we will stand up with this answer, right?
Yes.
Yeah.
Yes.
So you have to check for all the possibilities, and the most probable operator will be here J operator, not L operator. If it is S, then it will be minus a plus a, right? So okay,
Yes.
I'll discuss in the next page how it is. So because your total angular momentum will have the all the possible values. So you can see it if you consider x as jx, y as jy, and z as jz, it is following this relation, right? Now your z operator is behaving like jz, and it has the eigenvalues plus minus mj each term. Now mj is your basically 0 plus minus half plus 1 plus 3 by 2 plus minus 2 plus minus 1. It is possible for spin half, spin 1, anything, right? Not only spin half, let's say to spin half. So the possible answer is option C. I mean, by that analogy, we can say it should be analogous to your z component of J vector. Is it okay? Is it clear?
Yes, sir.
Okay, fine. So I think I am going a little bit first. So I think this will be the last question for today from my side. Okay, this question I want you guys to solve. Okay, let phi naught denote the ground state of hydrogen atom. Choose the correct statement from those given below. First option is given. This operator is defined as computation of Lx and Ly operating on phi naught state is 0. Second option is J square operating on phi naught, that is equals to 0. Third option, that is L dot S operating on phi naught, that is not equal to 0. And last option, this operator, that is commutation of Sx and Sy, that is operating on phi naught equals to 0. So you have to find the correct option from these four options. Okay. Take 5 minutes maybe. Think about this. What should be the answer? And let me know. Is the question is clear to everyone? Aparna, Sejal, Amit?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay.
So if we see the ground state of hydrogen atom, it has azimuthal symmetry, and from the first option,
Hmm.
it will be IH cut LZ. So
Hmm. Hmm.
LZ can be written as del phi. So it
Hmm.
should be 0. So A
Okay.
should be the answer.
Okay. Anyone else?
And so from a second perspective,
Hmm.
because it is in the ground state, it's supposed to have angular momentum value 0, which is only
Hmm.
possible when Lx and Ly both are 0.
Hmm. Right. Both the statement are correct. Actually, option A is correct. Yeah. So what precisely said? So what Amit has said actually, that is actually that you can explain precisely that when you just think about the hydrogen atom ground state, it will have only radial part, right? It will not have any azimuthal part or phi dependent part. And Lx Ly commutation, this will give you I h cut Lz. Now Lz is your minus I h cut del phi, right? So when you will differentiate this, you don't have any phi dependent term, so we will get 0. And also what Sejal said, that's logically, that is also correct. Your ground state, your LZ should be 0, right? That is also correct. You will get the eigenvalue as 0. Both the perspective is correct. Fine. So you don't have to go for the other options. Obvious second option cannot be correct. Either you will be have plus half or minus half, because you will get I cut SZ, right? This thing we have to calculate idea, and this is not 0. You will see it will not be, so it will be actually 0. I think it will be 0. I have not calculated. Can anyone check this once? How to check this? How to get this?
So it would have to be 0 because L is 0.
L is 0. So J is your J and S value is same, right here. So J square minus S square will cancel out here, right?
Yes, sir.
Yes, so it should be 0, and just J is also here, J square your is not equal to 0 actually. It cannot be correct, right? So obviously, so if you just start with the first option, you will get the correct option. Even though to cross check, you can check with the other options also to ensure yourself. Okay, anyway, I have already discussed these things, you can see. So for your kind information,
Sir?
the yeah.
But the difference will become evident when we are not dealing with the hydrogen atom, but some other
Yes, yes,
potential which is
yes.
not central.
Yeah, obviously. Then your wave function will be changed. Your okay, what you said, if you not
Uh,
have hydrogen
mm,
atom,
so
then
even then, in the ground state,
hmm,
option
hmm,
A
hmm,
will
hmm.
hold, but that argument will not hold of central potential.
If your potential is not central potential, you are saying that.
Yes, sir.
Okay. So what changes will be there? Okay, let me think. Can you please tell what changes will be
So
there?
option A would still hold because in
Hmm.
the ground state
Hmm. Right.
L is still going to be 0.
Hmm.
But if it's not a central potential, then LZ, but okay, then it'll still have to, because LX LY will
If it
always
is,
be
see,
IH
if it
cross
is not
LZ.
central potential, then you will have phi dependent term again. You may have. You can't say anything then. You have to see the check the what kind of potential is this now. So you have to have the form of the potential then. I can't comment like this directly. If you don't have any central potential, because it solely depend on your nature of the partial differential equation that is obtained from the Schrodinger equation. I have to check.
Yes, sir. So
You have
even so, when the potential is not central, we cannot
hmm.
say for sure that L will be 0
Mm-hmm.
in the
That's
ground
that,
state.
that that's correct. That's correct. That's what I'm saying. Yeah. Then we have to check the energy levels for each electronic shell. Okay. Yes. Right. But usually the questions are asked from the central potential only or hydrogen-like atom only. So okay, that's a good point, Sejal. Okay. Fine. So this was the last question, I think. Yeah. Okay. Now your questions, because this is the last class before gate. Your examination is on 11th, right?
Yes, sir.
Okay. First, let me ask any
Yes,
doubt.
sir.
Any doubt about these questions? Today we discuss 8 questions. I think it was a little bit quick, but the question was. I mean, the solution was for apart from the 2-3 questions. I think one first 2 questions, the solution was very short. If you just apply your concepts, then you can get the answers easily. The thing is, any doubt about the questions? Any questions you need to discuss again?
Clear, sir.
Okay. Okay. Then I am stopping my presentation and I'll. Okay. Any questions from you guys? Any doubts?
Sir,
Sir,
did you?
Yeah.
previous videos are uploaded in YouTube channel, right?
Hmm. I uploaded all the things, I think.
Okay, sir.
Can you please check? I think I have. Last week I didn't take any class because first I was informed there will be class up to 23rd, and also I was busy, so I informed them I will not take class on, so I'll take the 31st. So last week I didn't take the class. Today I decided to take the class. Yeah.
Okay, sir.
Yeah. I think it was not updated in the portal. I told them before 2 days before the class. Anyway, I think all the videos are uploaded. Today's video you will get after 9. I will upload after some time. Not an issue. I may upload after 30 minutes also. I'll get the solution. And I think I have also summarized all the solutions from 2021 2022 for your convenience. You can get the full video of solid state, full video of electromagnetism, atomic physics, some questions. You can check that if you want. And apart from that, anything else I missed? I didn't remember. Can you just give me a reminder if I missed something?
So,
Yeah.
so in 2022 paper,
Hmm.
question number
Hmm.
40, there was a question about identifying which of the following will be Hermitian.
Okay,
So,
can I see the question first? I have the question paper. Let me check the question. Okay, I
yes.
didn't see the question paper. I have to check the. Just give me a minute. I'll open
Okay.
the question paper for you so that you can tell. Just one. That is 2022. You are saying, right? 2022. Okay. Gate physics 2022. Okay. Which number question you are talking about? Can you just
40,
uh, sorry?
40, 40.
40. This is MCQ or NAT?
So, MCQ. One
MC.
question, one
Okay.
option is correct.
Okay. Okay. In cylindrical coordinates, that's the question. Is phi z, which of the following is Hermitian operator? This is the question.
Yes. Yes, sir.
Okay. 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 Let me check. S is here basically rho, or you can say R. So 1 by I iota. Okay. Okay. How to do that? Mm, okay, I will display the question. You guys may try. I will also try now. Okay, I will display the question here for you. Is this the question? Can you see?
Yes, sir, it is.
Okay, I will also solve and I will let you know if I can, and also you guys try. Okay. So see the question in cylindrical coordinates, which is the Hermitian operator? Okay, fine. So what's the definition of Hermitian operator? Can anyone say? Anyone?
It's conjugate means its adjoint should be equal.
Yes. So how will you apply that concept here? I can easily see the answer, which is the answer.
Sir,
If
option D.
why it should be option B,
D, D.
option D you are saying.
Yes, sir.
Why it should be?
H dagger is H only in option D.
But del x dagger equals to del. How can you tell that directly?
It is not actually the
That is not
answer.
actually the answer. I know. I know the answer actually because this is very similar. This is the question. I mean, if you think, okay, I'll tell you how I got. Let me check the answer first. Okay, if I am correct, then I can share my view here. I don't.
It's
It's option A.
C, C,
Option
sir.
C. Option C. Okay. Option C. Okay. Let me check one thing. I 1 by x. Okay. 1 by 2s. Okay. Then I have to calculate. Then I'm not sure. Okay. I was guessing. Okay. Let me do one thing. Okay. Let me just try how to check the Hermitianity of a operator, and I'll also do here. Then I'll let you know. Okay. Just give me a minute. Okay.
Yes, sir. I just recalled. I knew I was making a mistake.
Hmm.
What we actually have to do is we have to equate it with the known Hermitian operators, namely P and P. So then when we convert IH cross del del X into cylindrical, from there we can find what del del S would actually be.
Yes, that's why. That's your
Yeah.
momentum operator will be in cylindrical coordinate will be like this, right?
Yes, in terms of
Yes,
momentum.
actually, I now I did it wrong. Actually, basically we write it as minus I h car del del x, right? That is the Hermitian operator, but I missed out. Thanks, that was the cylindrical coordinate. The momentum operator is like this, right? So, is my point clear, Amit? What Cyril said?
Yes, sir, but how to convert it, I don't know.
Okay. So, okay, just I'll do that actually. That has to be done. If you do it like this, shy 1 star some operator shy 2 till x, or here it is your is. So ds, okay. Okay, so you take the dagger of this. So if you just do that, just give me 1 minute, okay? I'll just try and I'll let you know. Dagger star to dagger. Someone has written something. Network problem is there. Leave him now. Okay. Fine.
So some network issues are there.
Okay, sure. You can
So
leave.
no.
No problem.
Yes, sir.
Yeah. Okay. Amit, can you just wait for 1-2 minutes? Let me try because I have
Sure,
not
sir.
checked the question first. Okay. How to check? If you take 25 2 okay, fine one. Okay, now if you do this like 5 2 p or 5 So what was the question? That operators is I plus okay. Extra term I will be minus I2s. So basically, I mean, what I was checking, if some operator is Hermitian, then your phi 1, I mean, what you can write, if we can take two state, phi 1 and phi 2, okay, for this system, then first of all we can write some upward operator phi 1 so basically operator a cap is sandwiched between phi 1 and phi 2, so in the bracket form, then we can write it as phi, so basically phi 1 a cap phi 2, in that configuration we can write it as phi 2 a cap phi 1 whole dagger, right?
Yes.
And also, so it will be equals to your, if it is Hermitian, then phi 2 a cap dagger phi 1, it will be equal to your phi 2 a cap phi 1 whole dagger. Yes, that's the thing. So I want to apply this thing here. So now it is given in your options, that is integration. If I convert into integration, then phi 2 1 by I del is phi 1, and your integral will be on the volume. That is, what's the volume element in cylindrical? What is it? That is S ds d phi dz, right?
DZ. Yes.
S ds d phi dz, right?
Yes.
Okay, fine. So if I take this as dagger, so because I am in the second term, okay. How will I comment it from that? Then it will be minus of phi 2 I minus I, then it will be plus I, and it will be plus del is dagger phi 1. Okay. Okay, I think some calculations are important. Amit, can I send you the solution after the class? I can send you. I have to calculate these things. I have to check all the, and I have
Yes.
to check whether it can be solved very easily. I didn't see the question. I am seeing the question for first. Okay, but this is the way
Yes.
how we check that I have already told you. Okay, I can write in the screen. I mean, that.
Or we can just take the adjoint of it and see if it is equal.
But the thing is that if you take the, you can't say direct adjoint of ddx of adjoint equals to dx, because usually what I remember, the adjoint of ddx is minus dd of x. Okay, so that comes from the that is the Cartesian coordinate. But in cylindrical coordinate, I have to check. So the one thing, just what I was trying to use, just give me 1 minute. I will share my screen.
Also, you can assume money.
What Sejal has said,
Wait one
that
second.
is actually correct. If you can identify this, what is your sorry, just can you see my screen?
Yes, sir.
Okay, just let me add one thing, one slide here. Okay, let me try to write here. It is it's coming. Okay, just wait. Okay, so what
Sir, I think we can treat del S as iota and then proceed.
del SS?
Because iota, because it if we kind of correlate it with del S as del X, then we know that del X has to have the property of I mean it has to be equivalent to iota, because iota del X gives us a real thing P.
Yes, yes, yes. That's why I'm saying. So basically, del x of dagger is basically minus del of x, right? Can you
Yes,
verify
sir.
this? I mean, I remember that. That's why I'm saying. I have to. If you can verify this, that will be great. I mean, I remember that. Usually, I use
So
in my calculation.
just as iota time
Right,
dagger of
right,
iota is minus iota.
right, right. Exactly. That's the thing. Minus iota h ka del x. This is the gives a real thing, right? So if
Right.
you take it dagger, it should be like this. So it will be like iota h ka del x dagger, right? But it should be same. It should be same as minus iota h ka del x, right?
Right, sir.
Yes, sir.
So that means your minus del x is basically equals to del x dagger. So usually what I wanted to do, I mean the formal procedure that I am just writing it here. You can see my screen, right?
Yes, sir.
So dagger is basically phi 2 a cap 5, right? Now we can write, if it is Hermitian, then phi 2 a cap dagger phi 1, right? Right.
Yes.
So if we just take this, let me check one thing. I am trying to do that. If you take phi 2, now your, let us take first option, del is dagger phi 1 sds I will take, okay, because the volume element is sds d phi dz. Is it correct?
Yes, sir.
Okay, So is this the correct way to do, or I can take this, then I can do the dagger? That will be, I think that will be great, because this will be a
So
little
you
bit.
can take Shy2 and Shy1 as equal.
That doesn't make any sense. I mean, that's okay. I am making it general. Okay, that's just wait for 1 minute. I will take this thing first. So I will take this part here. Integration phi 1. Okay, 1 by iota del s uh, phi 2 ds s will be there. Other part will be okay, I am leaving that part. So what I can do, if I can represent this as this, then I can comment this is a Hermitian operator, right?
So, but you are missing the complex conjugate of the Shy1, I guess.
Right, you are saying that.
Ah, yes.
I have to think about this, how to go from this step to this step, and have to recheck. Okay, any idea how to do that? So we can use one thing, that is the 1 by I integration of phi 1. Sorry, my actually I am using this screen as vertically, so my writing will be bad. uh, S del phi 2 del s ds. Okay, if I am starting from there, then what can I do from here? Okay,
So why can we not directly comment from 1 by looking just directly from 1 by I del del s that it's real, so it has to be
that's the one thing.
permission.
That's the one thing to that I understood what you are saying. So you are, so from that concept, though, that should be two answer possible, right? I am discarding this. Okay.
Yes,
So
option
what are
B
the
and C.
options?
So these two options are possible, right? Then also this option is not possible, because you are converting your momentum like this. You are saying that, right?
Yes, sir.
But if that
So we
logic
have to
comes,
come up with something for S also.
hmm, but that is the formal way that I remembered. I mean, I have not done this for a long time, but that is the usual thing we used to do. That just compare these two things. If it is equal, then it is Hermitian, or like that. I have to do. Okay, I'll. So what I can do, Amit? I will just do it. I mean,
So,
yeah.
so can you just take means assume any uh,
Hmm.
exponential wave function and then
Exponential with
just to simplify that integration and all. Or we
mm,
can just assume any wave function
mhm.
and then take the
Okay, just give me
means
1 minute.
if we can find the eigenvalue, if it is real, then it will be Hermitian.
How will you do that? Can just 1 minute. Huh? I'm displaying my. Okay. Huh. Tell me. Yeah. Now please tell me. Actually, I missed something. Actually, I was I am separating my keyboard from my tab. That's why. Yeah. Yeah. What you are saying? Can you please repeat?
So if we assume any wave function such that we can find the eigenvalue,
Hmm.
so if it is coming real, then it will be Hermitian.
See,
Means
for
operator.
operator, it really doesn't matter on your wave function, first of all. If it is Hermitian, then it's Hermitian. What kind of system is this? Is it
For
really?
means I mean we can if we take the exponential and then operate uh, like del del x or something like that, so or integration, so we will finally end up with exponential of something, so the so that's why I am saying.
Okay, just.
Sir, actually, I think we were missing out the formal procedure in
Hmm.
which what we actually equate is bra psi
Hmm.
and ket a psi with bra a psi with ket psi. These two
Hmm.
have to be equal for the for checking the
Yes.
So
hermeticity.
I am
So
writing
Yes.
it again. Okay, I am writing it again. Just see if I am correct. Okay, phi 1 star or dagger you can say. It's okay. A cap phi 2. So this should be equal to your sorry, this will be dx or something. That will be as ds for here. Phi 1 sorry phi 2 no, sorry phi 2 a cap phi 1 phi 2 star dx whole dagger. Is this correct? Have I written correct it from? Because this should be phi 1 a cap phi 2. This is this and this is phi 2 a cap phi 1 dagger, right? Now it is Hermitian, so it should be
But sir, she was saying another way. We also calculated that way.
what?
Means in Dirac format, we can write bra a phi
Hmm.
uh, cat psi must be equal to bra phi a cat psi. Means cat of a psi.
State of Asia. Can you please repeat again? I will write then.
So
so
bra of
basically we are saying that we can write it in integral form as
Hmm.
psi 2 a psi 2 star a psi 1,
Hmm.
and that should be equal to
Hmm.
a psi 2 star psi 1.
Oh,
So the
okay, okay,
position of
okay,
A
okay,
has
okay,
actually
okay,
changed.
okay. You are saying like this. So this should be a dagger. So you are saying a shy 1 star or dagger shy 2
Hmm.
dx. You are saying like
Yes, sir.
this. Okay, okay. Then if you can do that, then what will be next step then? If you do that.
Sir,
Hmm.
as far as I
Oh,
think,
acha,
because it involves.
because of the Hermitianity, you can write it like this. You were saying that. Okay, okay.
Yes,
I
yes, sir.
got your point. I got your point. Okay. So this will be phi 1 star. Now, if it is 1 by I del S and you have psi 2, now SDS, right? Then what will you do then? SDS.
So now, as far as I think, what's going to happen is because it involves derivatives, some of the terms are going to get cancelled out.
That's I think then you have to apply that by parts, right? For that,
Yeah.
I
yes,
think
sir.
So
so.
ultimately, we'll get one of the options.
Mm, is del phi 2 del s. Get this. Now you will apply the by parts. Though you can do this. Okay, Amit, what I will do? I will calculate this. I will send it to you. Okay, just take it like this, and I will try to simplify this. I have to check these things again. The tricks. I have to just revise these things again because
Okay, sir. I
I
when
didn't.
tried it, but I couldn't get the answer, so I asked you.
Yeah, yeah, sure. I may send you the answer actually how to solve
Okay, sir.
this easily. I have to check these things. There's some tricks involved in this, some to solve it easily. If I found that, or I mean, I could not remember these things exactly how to solve this type of problem. Okay.
Yes.
Anything else?
No, sir. From quantum mechanics, this is my
Okay.
doubt.
Okay.
I haven't revised four subjects, I guess, so far.
Sorry. Four.
Four subjects yet to
Okay.
revise.
Oh, okay. 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 Fine.
So,
Yeah.
what I meant was that we may not even have to integrate because when we
Mm-hmm.
interchange the position of A and we bring it in the beginning, so when we write A times psi 2 star psi 1,
Mm-hmm.
in that process, because it involves derivatives, the derivative will act on both psi 2 star and psi 1. So we'll get two terms. So in one of those options, the second term will get cancelled and the final answer will come equal to the, you know, both of them will turn out to be equal. That's what I think should happen.
But for the option
Because
B, then how will you comment like that? Because both are similar type, only two factor is missing. So I think you have to simplify the integration, then you can find it. Otherwise, I have to do the explicit calculation, then I can comment
okay,
on
so
that.
then yes, maybe we have to.
So, but one good point is that is the momentum. If you convert, that will be Hermitian, and that is cylindrical coordinate. That is like that, right? 1 by del s 1 by 2 are like that. It is coming. So from that you can easily say, but I want a formal
But
solution for this. Hmm?
sir, then okay, and that is R also. Yes.
This thing, because uh, if you consider the PR. Here's a 2 mark question, I think.
Yes.
Okay, I'll check this. Okay, I'll see how to simplify the solution. Okay.
Okay, sir.
Yes, sir. I'd also solved it a long time back. If I can find it, I'll surely share.
I also did it in my bachelor's. I forgot all the things.
No, sir. I did it while doing these questions and all last year, I think.
Oh, okay,
And
okay. This type
yeah.
of question I used to solve in my bachelor's, because this is a, I think Hermitian, this is a Hilbert space, that chapter was there. In that chapter I used to do this thing, kind of thing, in my first year of bachelor's. So I didn't touch these things for a long time. Okay, fine. Okay, just try this. I'll if I can get the solution properly, then I'll send you. Okay, Amit.
Okay, sir.
Okay, any
Thank you, sir.
doubts?
Sir, in one of today's questions,
Hmm.
you said that we have to consider the maximum possible values J can take. So
Hmm.
we take
Hmm.
uh, 0, plus minus half, and 1 and all.
Hmm.
But at a time, how can J take both? I mean,
How
it
can
will go from minus J to J. So so at a time, it will either take integer values or it will take half integer values, no? Or
no, no, no. I
both
didn't get
of
your
them.
point. Sorry.
So the answer that we take,
Hmm.
it was 0, plus minus half, plus minus 1, plus minus 3 by 2, like that.
Hmm.
Is it possible for J to take half integer values and integer values simultaneously?
Not simultaneously. So if it is a spin half particle, then spin half particle, if your L values will be always integer, right? I mean, if you consider an S value is always either half plus half, then your J value will be always integer multiple of half, right? But if you
Right,
have
sir.
spin 1 or spin 2, I mean, integer multiple, spin is integer multiple of your integer. I mean, I am saying that like spin 1, spin 2, spin 3. Then it is possible to have the integer value of J.
Yes, sir.
So in the question, it has not been said that it is a spin half particle. It is said in general what's the possible values of eigenvalues of J. So you have to consider
Yes,
all the possibilities here. Either spin 1, spin half particle, or spin integral particle.
yes, sir. But in either of the situations, we can not get that answer, no? Because it'll either be 0, plus minus 1, plus minus 2, or plus minus half, plus minus 3 by 2, and that so on. How can we
I
have
don't.
No,
both
Okay,
of
not at
them?
the same time, but
let me go to the solution. I think that will be helpful. Just
actually, the answer, I guess, it is asking about the set of all
so all
the.
the possible values, not the at a
Yes,
time it will not have all the values. All the
yes, but
possible
they
values
can
of
be
Z. Yes.
integer or non-integer. So
Non-integer.
we have to
It cannot be
calculate both.
simultaneously integer or non-integer. Yes, that's correct. So it is asked in general what's the possible values of eigenvalues of Z. Here it is asked. That doesn't mean ki you will have at a particular time you will have either integral or non-integral value. That's not the case. Sejal, did you get my
And the
point?
set should like the set
Yes,
should contain all the answers.
Yes.
but I'm not sure whether in real time we'll be
No,
able
no,
to
real time,
interpret it that
it's
way.
real time. It will not happen. Either it will be integral or it will be non-integral. That's the thing.
Okay.
So, but if you consider the all possible spin configuration, that spin half or I mean spin half integral or spin integral, then everything is possible here, right?
Okay, sir.
Yeah, that's why the question is. That's why I was saying if you consider the LX only, SX only, then you will be end up with wrong answer. So if the question is little bit tricky, you have to understand what operator you have to choose here. Okay. Okay. Anything else?
So because it's very easy to to mistake answer A also here because
Yes, that's the thing. That's if you choose this thing, that what does it mean? When should it you should get this? If you consider your spin half particle, and then it is not possible, right?
yes,
Then it is not possible. It is possible only when you will take this spin integral particle, right?
yes, sir.
And it is possible for your spin half particle. And it is possible only when you consider your x as sx, y as sy, right?
So when is B possible?
B possible when B is a subset of all the possible values of spin up particle. You can see there is no negative values, only positive values are considered, right? So this is for spin half particle, right? Because if you consider your L value 0, S value half, then it will be half. Okay, 1, it is also 1 and 2. So it's a mixture of integral, non-integral, but the negative values has been discarded from here. So this is the subset of this, right?
So B cannot be the answer because for every L, S, or J, we have positive and negative
And that's why I'm
values.
saying this is the subset of this. You can see.
Yes.
So this is possible. This is a subset of this. This is only taking the positive values of JZ. I think, yeah, all possible values of positive JZ
Without zero also.
without zero also, right? That's the thing. So Sajal, what I am saying, in this case also it is spin integral and spin half particle has been included. Okay.
Yes, sir.
But here it has not been considered that here negative values of jz or mj, you can say.
Yes, sir. So
But
this can be discarded.
this is a subset of this. So this is, if it is a multiple option correct, then there should be answer C and B and C, obviously. But here it is set of all possible eigenvalues, then it will be the answer. Okay. This
Confusing question, sir.
this is a confusing question. Yes. Okay.
Okay. And sir, did you glance over that solid state question? How
That
hexagon can give us a primitive lattice in 2D?
hexagon primitive, which question are you talking? Maybe I missed, just let me check. You send me the question, right? Actually there's lots
Yes,
of
sir.
work, I may miss some questions. I tried to
So
focus.
that's from CSI net from
Oh,
Feb
which
2020.
oh, okay, just let me open the question then.
Feb or September, I don't remember.
Okay, I think
September.
Sejal send me the question, I think, right? Sometimes
Yes,
back.
sir.
Okay, let me open the question then. Just give me a moment, I will open the question. Okay. Net Physics 2020. Okay. Did you remember the question number? Okay, let me check. Hexagon one. Okay. Oh, what was the question number? That was okay. In this, oh, I do 51. The figures 1, 2, 3 below represent the 2D. Okay, equilateral triangle, a rectangle, and a regular hexagon. This question you are asking?
Yes, sir.
Okay. Let me read the question. Which of them can be primitive cells of a previous lattice in 2 dimensions? Okay. Hmm. Fourth. Hmm. One, two. See, first two is obviously your primitive unit cell that I can easily see, right, Sujal?
I think only rectangle can be called primitive in 2D
Why it is so? Because you will have
because
contribution. Okay, if I draw the crystal structure for this, okay, let me check one thing. So,
every corner will be shared with among four rectangles. So one
hmm,
fourth times four.
just let me check. Just give me a moment. I will draw the total crystal structure, then I can understand here. Okay, so this is shared by 1, 2, 3, 4, 5, 6. So, okay, just give me a moment. 1/6 is shared into 3, so this is half, so this is not possible. This is rectangle. Okay, this is 4. If it is hexagon, then it should be like this. Is the option 2 and 3 correct?
Yes, sir.
To
Rectangle and hexagon.
that will be, yeah. If you draw the crystal structure properly, then you will see that. So basically, see how I did that. Maybe your perspective may be different. I will ask you. So if you draw the total, I mean your surroundings. This is the previous lattice. If you just draw the structure, okay, I can do it for you. Okay, just let me do it for you because I have the opportunity to write on screen because I bought recently the pen for this time. So that's why. Just give me a moment. Okay. I think you can't see my screen, right?
No, sir.
No, sir.
Oh, okay, okay. Just give me a moment. Now you can see, I think, right?
Yes, sir.
Yes.
Okay. So see, you have first that triangular part, right? Maybe my drawing is little bit horrible, but just okay. So consider this, okay? This is a triangular. You consider atoms here on the lattice part, okay? So now this atom is shared by how many triangles? 6, right, Sajal?
Right, sir.
So is every atom has contribution 1/6, right? Now
Yes, sir.
just 1 minute. So if you consider only one unit cell or this unit cell of the previous lattice, then it will be multiplied by 3. So it is coming half. So it is not possible. It is not a primitive cell, right?
Yes, sir.
But if you consider the hexagon, consider this point. Now you can easily consider it has a 1/6 contribution, right? It has 6 side now. So it is coming 1. So it is possible, right? So if you draw the hexagons over here, you got my point. So you have
Sir,
6
it's one third. How is it 1/6?
is 1/3. Why it should be 1/3?
Yeah, but the contribution is one. Yes, one third.
Why it is 1/3
So
you are.
shared by yes, sir, because it's shared with three hexagons. The top one, if we see.
This is 1/3. Oh, acha. Right. Oh, sorry. So this is 1/3. But this should not be primitive. Okay. The answer is different from it. I mean, it is saying that hexagon is also primitive.
Yes, sir.
Oh, acha. I think the two basis system. That's the same. Oh, okay. I got the point. Actually, graphene is this is a graphene-like structure, and graphene is a primitive cell with two bases. That's the thing. I think then in that case, oh, okay. I got the point now. Then I have to discuss lots of things. Okay. It may be primitive cell, but in some defined context. Okay, I'll try to explain. Let me see if I can remember that thing. If you look at the graphene structure, can you just give me a moment? I will just open the graphene structure from the book so that I can explain it easily. Just give me
Yes,
a
sir.
moment. It will be helpful for me. Just give me a moment. Okay, if I see the graphene structure, अच्छा, okay. Number of the primitive cell is 2. Actually, this is a little bit confusing because in this, so I am seeing a paper where it is written that is graphene's unit cell is primitive cell with the basis 2. I mean that words I now remember, but that is certain type A. For that I have to discuss lots of things. I think, but
So
how?
graphene cannot be considered here, right? Because it's not a 2D structure.
It's a 2D structure in the question, right?
Yes, sir. The question says two dimension.
Graphene is also a 2D structure. Graphite is
Uh,
not. Graphite is a 3D structure. Graphene is a one layer of
okay,
graphite.
okay, okay, okay.
So that's related to graphene. The structure I can see, this is not a hexagonal close packed structure because there is no middle. This is a hexagonal close packed structure. So if you have, so this is the thing, right? So hexagonal structure is not primitive, that's for sure. Okay, now it is also making me confused, but here it is written that it's a primitive unit cell with basis 2. So if you can, okay, I have to read it thoroughly because read this paper. Okay, just wait. This primitive unit cell, okay, number of B to B. Okay, if you say the previous lattice, then you will have number of inside atoms 4, corner atoms 2. So natural numbers atoms in there is 6. Side of the unit cell parameter E. Number of second nearest neighbor is okay, 6. Area of primitive unit cell. Cell 2. 2 atoms of the graphene inside the primitive cell. Okay, so what it said, I can explain it to you, but it is not also convincing to me right now. Okay, I can just draw it here. Okay, just give me a moment. I will So the answer is 2 and 3, right? Rectangular and hexagon one in the question, right?
Yes, sir.
Okay, I will just explain what it said here, but I have to understand this properly. I didn't think about it right now. Okay, just let me draw it first. If I draw this graphene structure, if I consider 3-4 lattice or unit cell, say, so you can see it is not a previous lattice first of all. Okay, why it's not a previous lattice, can you say? What's the definition of previous lattice? Anyone? Sejal?
Sir, this is something I always tend to forget.
Previous lattice is like each atom should have identical environment. Okay, but see here two kind of atoms are there. Okay, I'll draw one more row so that it will be clear to you. My drawing is little bit weird, but please try to understand from the structure. So every hexagon are identical. Please consider this. See here, if you consider this, okay, let me start from this A and this is B. Okay, see this point and this point doesn't have identical environment. Can you understand? See, if you consider this A point, in
Yes,
this
I got it.
direction you don't have at the middle you don't have any atom, but for this at the direction, if you say that A naught, this should be A naught. So along this A naught direction you don't have any atom, but this B type of atom have atom. So all the atoms doesn't have its identical environments. That's why it is not previous lattice. First of all, did you get my point?
Yes, sir. Yes.
Okay, so there is two types of atoms. Okay, not C. So that's why in graphite there's A stacking, B stacking. So if one second layer overlaps with A atoms, then it will called A stacking. A type of atom may stack on B type of atom. It is called AB stacking. So this type of thing comes in graphene. I mean bilayer graphene, not single layer, obviously. Okay, let me explain what does it say. Then it said only A atoms, B atoms from the basis they have surrounding. So either connect by A atoms, B atoms, some number of cell. Okay. Now, if we connect, so this is A, this is again B. So if we connect B atom, so let us identify A, this is B. So if we connect this B atom, this B atom if we connect, and this B atom if we connect, this is A, this is B. I don't know, my drawing will be horrible, but please try to understand. This will be a hexagon. Okay, I don't know.
Yes, sir, got it.
This will be a hexagon. Let me draw it. This will be a hexagon. So this is not, and the length scale was not correct, so that's why I think this will be okay. Let me exaggerate this. Can you understand these things now? Is it clear to you?
Yes, sir.
This will be a
Yes,
hexagon
sir.
if we connect B atoms only. Okay, it is said like this. So if you consider the, now this is a Breville lattice, right? Because all the atoms in this, I mean at the corner, will have identical environment, right? Is it okay?
Right,
Yes,
sir.
sir.
Right? So side of the answer be now, okay, there are something called basis. So I think this was actually a little bit confusing for me. Here it is said that there are two atoms in the graphene in the primitive cell. So if you consider this primitive cell, so there will be A type of atom, this will be B type of atom, this will be A type of atom, right? So what's the total number of B atom in this hexagon, larger hexagon? Can you calculate? This will be one third one. Can you please calculate this number of?
Sir, it's 1 6 1 plus 1 1 2. It's 2.
Is total 2, right? No, there will be
No, it will
there will
be
In
be
the
1
middle,
third
there is one.
3
2
atoms.
Three.
6. 3 atoms, right? 3.
Yes, three.
It will be 3.
Mm.
Corner atoms will have contribution for, if you see the B atoms now,
One third times
like this,
six.
so this will be 1/6 contribution, na? No. If you just consider the another one, then it will be go like this. And okay, let me draw one more so I can understand more far better. Okay, so this. So B atom will contribute to okay, sorry, this will go like this. This is a little bit weird for me. Okay, this will be one third, right?
Yes,
B
one
atom.
third into six plus one.
No, 1 third into 6 plus
And
there
then,
are one atom A plus 1. Okay, okay. You are saying that B atom is like this. So this is
yes,
3. And A atom is number of A atoms. They are coming. Here is also one atom A. Sorry, I missed that. So
three.
three A atom is coming. Total 6. Okay. Now what can I say from this? Number of primitive atoms of primitive cell. Atoms of primitive inside the primitive cell. But it is saying 2 atoms inside the primitive cell. How it is coming there? If I say about the primitive cell, then it should come. Still, I don't understand the comment here. It is given. Side of that is. Okay, what they are doing like this. This is the unit cell, one third, 1/6 of 2 into 1/3. Just give me a moment, huh? Let me understand what it is written here. Just number of nearest neighbor is 3, that's correct. In 2 dimensions, there will be close back if the number of nearest neighbors are 6, but here it is 3. So packing will be loose. That's the thing. Second nearest number distance E. Second nearest neighbor is 6. Area of 6 into 1 by 3 root 3 by 4. Right. So if I draw the sorry. If I draw now, if I consider this structure, the larger one. So there are atoms, and you have like this here one atom, here one atom, have one atom here. Did I miss something? Sorry, I did something wrong. It will be connected to like this. So this thing, and this will be connected to like this. This will be like this. This will be like this, and it will be connected to.
so if we see the area of the
Hmm.
larger one, then it should cover actually three times the smaller hexagons.
Three times the smaller hexagon. So
Yes.
the mm,
So per small hexagon, we are getting actually one B and one A
one
atom.
B and one A, right? So
Yes.
if you just consider this, no, I am looking at this. If you consider this hexagon, sorry, this triangle. So I am dotting it out actually. This triangle. There is B B B and one E. Then it is what's the contribution of this? There is one A one B. Is this no? I'm trying to find the smallest unit cell among which the two bases are present here. Can you find that? Um,
So it will be on an average, I guess, means not
mm,
generally for one unit cell, but on an average
mm,
should be basis two, means one of A type and one of B type.
That is written here. It is a primitive cell consists of two bases. One is A, one is B. So this is not. I mean, what we know that is the primitive cell has effectively one atom in that unit cell, right?
But
So
the if we see the bondings, then this has actually means resonance bonding, so that's why the exception probably.
not exception. I
Sir,
actually I have to see the
uh,
logic here because yeah, for two basis system how to define the primitive lattice I have to check once. Yeah,
sir,
please say.
actually, I am getting one, but it's not a hexagon. It is actually a parallelogram. If we just simply join AB and we consider AB as one basis and then
Ah,
join,
this AB is one basis. That's the thing.
yeah, this AB, so they make four vertices of a parallelogram.
Hmm. This
That is
AB.
primitive, but that's not hexagon.
Hmm.
That is brevi and that is primitive.
Hmm. That's why I think it is said here. It is a primitive lattice with two bases, because yeah, that's correct. So for two bases system, I think it is defined like that, right? The primitive
As they
cell.
are different,
Hmm. Because usually
means they are
we deal with you deal with identical. I mean that's
yes.
the. So basically, as it is not a trivial lattice, so that's why you have to. I think that's why it is commented here: the two atoms of graphene inside a primitive unit cell. Yes, right. So Sejal, you are saying that your this AB, and which other one? This one, this pair you are saying.
No, sir.
let me let me
The
let
the
me
other
let
A, the other A
let me
left.
let me draw it again. It has got. Okay, I have to be clarified. Okay, this is getting confusing for me now. I have not dealt with this crystal structure for a long time. Okay, just let me clarify these things then.
Probably that's why you were given this class. You will revise with us.
Hmm. Sorry.
So, like you don't get time to revise all this, so you will revise with us.
That's correct. Yeah, it's also beneficial for me, for to revise the fundamentals. I This is the problem in PhD actually. When you involved in, so you start to forget the basics, but it is good to revise the basics every time. Hmm. And we know this is a structure with this, but never cared about this thing. Okay, so what are you saying, Sejal? This is A, this is B, this is A, this is A, this is B. Oh, my battery is low. Okay. So, Sejal, can you please tell me what are you saying?
So we join.
This AB I can
Uh,
join, right? This AB is a pair.
yes.
Okay, then
And similarly, everywhere.
okay. If you are saying that if you join this two, if you
Yes.
join this two,
Yes, sir.
okay, okay. I got your point now. So if you have to draw one more, right?
In the bottom row, we can get two more pairs.
Here you are saying in this point.
In the lower row of hexagon, sir, we have another AB set.
So here one you have set,
No, not this one, sir. In
not
the
this
same
one.
orientation.
Oh, in the same orientation you were saying.
Yes,
So
sir.
you will have this.
Yes, sir.
Okay. Then if you just consider this, you are saying like this.
No, sir.
Sorry.
No. It will be joined with. It will be joined horizontally. The joining will be done horizontally.
Join them horizontally. Why?
Yes, sir.
Mm,
So these two will be joined with a horizontal line, and that the above one will be joined with a tilted line. It will form a parallelogram.
okay. So it will be like this. You are saying. I still didn't get your point.
May
So
I share my screen, sir, if
I think you are
it
saying like
serves the
this.
purpose?
You are saying like
Yes, sir.
this.
Yes. This is also right.
Okay. Then it's a primitive lattice with two bases, and the contribution of each basis will be 1/4, right?
Yes, sir.
That's a good thing I learned. I mean, I forgot these things for a long time. Yeah, that's how the graphene's okay. Fine. So for two basis system, we have to do like this. Good. Okay, I think you have clarified your confusion from this discussion.
Sir, I want to confirm whether this is indeed the answer
No.
because they asked us to.
This is so. It is written in the statement that this is the primitive lattice with two bases. That's for sure, and that is correct, obviously, because sorry, what I have done. Okay, this thing, right? Sorry. Yeah. This is a thing. Okay, I'll check this and I'll send you a mail to confirm this. Is this the way? But the statement is correct. Here it is written two atoms of graphene inside the primitive cell. But how to, is this the way? I think it is correct what you are doing, because actually two bases means you will consider this as a pair. That's correct, because when we talk about the graphene, there we say A type B type atom, and they form the basis of the system. So so if just give me a minute. I have to call. Mm, I don't know actually. I also learned from you for today this thing to for to verify the answer. But is this a way I have to check?
Yes, sir. I think it could be because when I'm trying to replicate this procedure in the triangular case,
Mm-hmm.
uh, I don't
Triangular
know whether we
thing.
get it.
Triangular. So you are saying the first. Oh,